Good day everyone. We are here to discuss about multidimensional scaling. Multidimensional scaling has become more and more popular both multivariate and exploratory data analysis that creates a map displaying the relative positions of a number of objects given only a table of distances between them. This table of distances is known as proximity matrix either directly from experiments or indirectly as a correlation matrix. The multi-part of the name refers to the fact that we are not restricted to constructing maps in one, two, or more dimensions. One of the goals of the MDS analysis is to keep the number of dimensions as small as possible. If more dimensions are required, you may decide that MDS is not appropriate for your data. The input data for MDS is in the form of a distance matrix. Thus, similarity matrix may need to be converted to a distance matrix. Proximity measures quantify how close two objects are. The program accepts three forms of proximity values: dissimilarities, similarities, and correlation. Dissimilarity matrices represent the distance between two objects. On the other hand, similarities represent how close two objects are. As I've said earlier, similarity matrices may need to be converted to a distance matrix. Thus, the formula would be: there are two major groups of methods for deriving proximities: the direct methods and indirect methods. Both direct and indirect methods of deriving proximity data yield the proximity matrix, which serves as an input for MDS programs. In many practical applications, it will be straightforward to ask the participants directly for their judgments of the dissimilarity or similarity of objects. Indirect methods, on the other hand, might be well suited to the investigation of basic perceptual dimensions, or in the case when of the objects under study already exists. In classical scaling, we seek a configuration such that the interpoint distances in the configuration will be approximately equal to the corresponding original distance matrix. We may wish to have a measure of how good the fit is. This would be useful for helping us to judge how many dimensions are necessary to get a good enough fit. In judging how good the fit is, the stress, also known as Kruskal stress, is calculated as replacing original distance matrix by disparities because we are now interested in how close the distances to the disparities. Classical scaling could be described as metrical scaling since, in contrast to non-metrical scaling, the fitted and original distances are expressed in the same metric. In metrical scaling, we assume that original distances can be transformed into Euclidean distances by some other parametric transformation.
Application of MDS in SPSS. Assume you are a mobile phone researcher and you want to know how similar your mobile phones are to each other. In order for you to create a perceptual map, you will need the help of SPSS. Now, you have 6 brands, namely brand A, brand B, brand C, D, E, and F. To create an identity matrix between these variables, you have to list these brands horizontally and vertically. Now, you have to ask the respondents how unique or how similar your mobile phones are to each other. For example, brand A, brand B, brand A from brand B, brand B from brand C from D, and so on, which means all of these brands will be compared to each other in different parameters. Well, these parameters could be anything. It can be based on durability, price, performance, screen resolution. It is based on the perspective of your respondents. You have to get their perceptions on the similarities of those brands and input them into this table. Now, this table shows that how what is the ranks of the similarities of different brands in accordance to performance, durability, or screen resolution. This table shows that brand A and brand E is considered to be the most similar because rank 1 is given to it. Next to it is B is brand B and brand F, which is rank 2. In this case, the rank 15 is given to brand C and brand F, which means that they are considered to be the least similar to each other. As a mobile phone researcher, similarities on phones is actually a disadvantage or is actually negative because you want to develop those mobile phones as unique to each other. Okay, now you have this data and all you have to do is to input them into the SPSS file. Okay, but first of that, you have to define certain variables. Now you have the brand names, brand A, brand B, C, D, and F. They are considered different to each other, so they are in strings, and they are also considered as nominal. These variables doesn't have a weight, and they were also based on a ranking scale, so the measures on these 6 different brands are on an ordinal scale. Okay. Oh, another thing. The reason there are zeros in this table is because this is an identity matrix, meaning brand A is considered to be the most similar to brand A, and it will entitle the rank 0. Same as to brand A to brand A, brand B to brand B, C to C, D to D, E to E, and F to F. Now, you have the raw data, and all you have to do is copy this whole table into the SPSS save file. Now, you have these 6 brands, namely brand A, B, C, D, and F. And you have these values, which are typically ranks. Now, in order for you to plot an MDS table, you have to click Analyze and then Scale. As you can see, you have 3 options available, namely PrepScale, ProcScale, and AlScale. Proxial scaling will be used if the data shown shows similarities on a lower triangular form. Whereas if you want to know the similarities or differences between variables on an upper triangular form, you will select AlScale. In our assumption, we will select ProcScale because we want to know the similarities between our phone brands. Now, the data format for the multidimensional scanning will be used. All you have to do is to check that the data are proximities on a 1 matrix source. Then, you will copy these 6 brands into the proximities column since they varies no weight and they are also based on a ranking scale. Next, you will check the model. As you can see, you have in the shape, you will see that the figure is a lower triangular matrix since these variables were based on similarities. But if your variables were shown in an upper triangular form, it just means that the variables were based on differences or dissimilarities. In our case, we will select that this figure is based on a lower triangular matrix. For the proximities, it is actually similarity, so we will change this one, and they were based on an ordinal scale since they were in ranks. For the restriction column, there is no restriction, so nothing to be changed here. For the options, you can see that there is a fixed amount of stress, so you can just, for the plots, all you have to do is to check if it is in common space. And for the output, you have to follow this format, and you have to check that the variables are on a common space coordinates with multiple stress measures. Okay? Now, this is your perceptual map regarding the observations or the results of the data you gathered. The datas or the brand names were based on a set points. They were based on set points on different dimensions. This figure shows that the similarities of these brands is based on how near these variables are to each other, which means brand F and brand C is considered to be the most similar among all of the brands. Brand B is considered to be the least similar compared to all the brands because it is really far compared to the distance of different brands. Brand C and brand E is less similar compared to the similarity of brand C and brand F. All in all, in this figure, if the two variables were quite near to each other, they are considered as similar.